Hi everyone, my name is Mrs. McCullough, if you didn't know that already. We're going to spend some time doing some enrichment assignments today. This is going to be for lesson 4.13, so be sure to have your pencil and your notebook so that you can take notes as we move through the video. I want to start by talking about the enrichment assignments and what they are and what to expect. So if you see here, you see semester 1, there's going to be 2 enrichment assignments for semester 1, and then there's going to be 2 enrichment assignments for semester 2. So this is going to be, they're going to be the same directions for every one of those assignments. The first direction is, or first step is to watch the enrichment video, which is what you're doing right now. The video is anywhere from 10 minutes to 20 minutes long. Now be sure that you're taking notes on the video in your notebook because you can use those notes for your semester exam. Now, not only are you going to be able to use these notes for your semester exam, you're also able to turn that in for part of your points. So you're actually going to scan your notes that you wrote, and you're going to actually attach that to your assignment when you submit your assignment. So it's really important that you're pausing the video and that you're writing down these practice questions so that you can submit those notes to me as part of your assignment. When you're done watching the video, you're going to actually go to the assignment itself. Now, the assignment has anywhere from 15 to 25 questions, but you do not have to do all of the questions. You just have to pick 10 of those questions. So just pick 10 questions that you feel comfortable answering, and they will be questions that you've seen before in the semester. So it should be a good review to practice some of those skills you've already learned. Be sure that you pick your 10 questions, you show all your work on a sheet of paper, and you work through those 10 questions. Remember, if you don't show all of your work, you won't get all of your points. When you're done completing this assignment with your 10 questions, you will also scan that into the assignment before you submit it. So just remember, the important part here is you're going to be doing 2 things. You're going to be watching this video, which you're doing now, and you're going to be attaching those notes to your assignment, and you're also going to be picking 10 questions from the list of questions to complete, showing all your work, writing out all your steps, circling your answer, and you'll attach all of that as well, and then you'll have that assignment done. As you work through these questions in this video, and as you take a look at the questions that you can choose from, remember that you want to choose 10 questions that you can pick to solve it. Any 10 on the list, it doesn't matter, but they do need to be different. They have to be different than the ones in this video. So I actually picked about 4 questions that we're going to go through together in the video just to help you refresh your mind and memory of what you've learned. Do not use those in your 10 questions. Those should be part of your notes. Alrighty, let's take a look at some questions together. This will be number 5 on your practice worksheet or your assignment. You can write this question down in your notes if you'd like, or if you've printed out the worksheet, just be sure to reference where it came from. And feel free to pause the screen if you need to at any time to write these down in your notes. So this one's saying that the area of a rectangle is 2/3 yards squared. So I'm going to go over here and I'm going to say, okay, I have a rectangle, and areas is everything inside, right? And it's 2/3 yards and squared because area is always squared. It says that the length is 5/9 yards. And this question is saying, well, what would be the width? What would our width be? Well, I'm just going to put a W there because we don't know. Now, what we do know is we know that area is equal to length times width. And I know that my length is 5/9, but I don't know what my width is. And I also know my area is 2/3. So at this point, I'm just plugging in numbers that I know. Now from here, my goal is to get the W by itself. So if I look at this equation, I'm going to draw my line between them. I'm looking at the side that has the W. And I'm looking to see, what do I need to get rid of? Well, it says that it's multiplied by 5/9. And anytime I want to get rid of a fraction,
I just multiply by the reciprocal. And remember, reciprocal is the completely opposite. It's a flipped fraction. So reciprocal just means to flip it. It's a fancy math word. You'll see it a lot. It just means to flip fraction. And once I've done that, what I've created now on the left side of my equation is 9 over 5 times 2 over 3. And then on the right side, the reason I multiply by the reciprocal is because I can cross cancel anything that's the same number on the top and on the bottom of a fraction. So you can see that there's a 9 on the bottom or in the denominator and in the numerator, so they cancel out. And the same applies with the 5. So you're really left with one W, which is just W. Now our last step when we're multiplying fractions is just to multiply across. That's 9 times 2, which is 18, and 5 times 3, which is 15. Now I'm going to change this to a mixed number. So I ask myself, 15 can go into 18. Well, it can go in one time, right? Because 1 times 15 is 15. And I have 3 left over out of the 18. Now we're almost done. You always want to check and see if you can reduce this. When I look, 3 and 18, I can divide both of these by a 3. And I get 3 divided by 3, which is 1. So I'm going to put my answer over here, actually. So I have 1 and 1/6. And then I need to make sure I have my units, which is yards. So my width in this example would be 1 and 1/6 yards.
Alrighty, for number 3, it's talking about Ivana, and Ivana works at a department store selling perfume and makeup. She earns $375 per week and 4% commission on her sales. So remember, commission is basically how much money you're making. It's like an incentive or a bonus. So she's going to make 4% of whatever amount of money she's selling. So if her items cost $3,000, she's going to make 4% of that. In this case, though, if Ivana's sales for the week are $2,513, what are her total earnings for the week? So the first thing I want to do is set this up as an expression and break it down that way. So you notice the first thing that I circled was the 375. Okay, that she's going to make per week no matter what. Then she's going to get a little bit of a bonus. So it says, and a 4% commission. So 4% of whatever she sells. So this would be how much she's making each week. Well, when we keep reading, it tells us this week that she sold, her sales were $2,513. So we're just going to replace this number for what she sold. Okay, I'm going to bring down my 375. And when I look at this, this is 4% of whatever she sells. We can't leave it as a percent. We need to change it to a decimal. So remember, to do that, we just simply take our decimal, which if it's not shown, it's at the end. Move it 2 places to the left, and then put your decimal there. So this is the same thing as 0.04. Okay, so this is where we are right now. Now I know I'm going to have to add eventually. I'm going to have to add my $375 to that total because the question's asking us for her total earnings. So the next thing that I want to do is I'm going to look here and I want to use my order of operations, which remember is please excuse my dear Aunt Sally. That's PEMDAS. And so that always tells us to multiply first before we add. All right, so I'm going to go ahead and multiply 0.04 times 2,513. And you can use a calculator for this one if you need it. And that gave me $100.52. So because Ivana sold $2,513 of items, whatever's at the store, perfume or makeup, she's going to get a $100 bonus that week. And then I'm going to add the $375 that she makes no matter what. And when I add those, it gives me $475.52. So this is how much she's going to make that 1 week.
Okay, for 17 it says, does the table represent a proportional relationship? And then justify your answer. All right, so we did see proportional relationships in Module 4. So we're going to just refresh what we remember about proportional relationships. Proportional relationships, remember, or graphs, when you're looking at a graph, there's a couple things that we have to make sure we remember. Our line has to go through the origin. And remember, the origin is 0, 0. So your line has to go through 0, 0 to be a proportional relationship. And then it has to have the same slope or rate of change. And remember, rate of change is also the same thing as change in y over change in x. So all of these mean the same thing. If it has the same slope or the rate of change, it's going to tell you that it's a straight line. So you're looking to see, is my graph a straight line? And does it go through 0, 0? Well, when we're given a table, it's a little hard to tell. We don't know if it goes through 0, 0. We could graph this and we could see. It tells us which ones are our x and our y. So we could say, okay, I'm going to make a graph. And I'm going to make my x be my cups of flour. Oops, flour. And I'm just copying what it says here. My y is my number of cookies. And I could say, okay, I'm going to plot, I'm going to make myself a pretty graph. I'm going to go 1/4, 2/4, 3/4, 4/4, which is a 1. 1/4, 2/4, 3/4, 4/4, which is a 2. I'm just going by fourths here. And I picked fourths because they're all fourths. And then I have 2, 4, 6, 8, 10, 12, 14, 16, 18. And I could go through and I can plot them. I could say, okay, 1/4, 2/4, 3/4. I'm going to go up to 12. And it's about there. And I'm going to graph each of those. I could do that if I wanted to. That's probably not the most efficient way when I have a table. So what I'm going to do is I'm going to show you a different way. Remember we talked about here, we're going to use this y over x. They should have the same rate of change. So I'm going to do y over x and see if I get the same answer. So for my first one, I'm going to get 12 over 3/4. Now that looks really messy, so I'm going to rewrite that so it would make more sense. Remember that this fraction just means to divide. So I'm going to do 12 divided by 3/4. That's what that says. These mean the same thing. And I'm going to make the 12 a fraction since everything else is by putting it over 1. And then I'm going to do keep, change, flip. So keep, change to a multiplication, and flip. And when I multiply this, I get 12 times 4, which is 48. And then 1 times 3, which is 3. And I'm going to leave it like that because I want to see if I get the same thing for every single time. So that's the first one. Now I'm going to go to the second set. The y number has to go first, which is the bottom number. So y over x would be like 36 divided by 2 1/4. Now before I can do this, before I can do keep, change, flip, I need to take my 2 1/4 and make it improper. So 2 1/4 is the same thing as 2 times 4, which is 8, plus 1, which is 9, so 9/4. So this is the same thing as 9 over 4. So now I'm going to do keep, change, and flip. So I'm going to keep my 36. I'm going to change my sign from a division to a multiplication. And then I'm going to flip my 9 over 4 to become 4 over 9. I'm going to put my 36 over 1, and then we're multiplying across. Now in this case, before I multiply across, I can also look at it and say, well, is there anything that both of them have in common that I can get rid of. Well, 36 we could divide by 4 or by 9 and get 4. And I could take 9 and divide it by 9 as well and get 1. So that's called cross-canceling. If there's a number on the top of a fraction and on the bottom, you can divide both of them by the same number to cancel it or to make it a smaller. You're reducing. And the reason I do that because now I have 4 times 4, which is 16, 1 times 1, which is 1. Now let me go back to that very first, well, let me put this here. So this one would be 16, that's my rate of change. In other words, what that answer is telling you is that you're making 16 cookies for every 1 cup of flour. Now I'll go back to the top one because we left that as 48 over 3. We can actually reduce that. If we do 48 divided by 3, we get 16 over 1. So far they're the same number. So far they're showing us that they're proportional. All right, now let's go ahead and do that last one. I'm running out of space. All right, so y over x would be like 60 divided by, and I'm going to go up here and just make this improper. So that would give me 4 times 3, which is 12, plus 3, which is 15, and then over 4. So 15 over 4. We know we're doing keep, change, flip. So I'm going to keep the 60, change my sign, and then flip the second one. Then I'm going to put the 60 over a 1 to make it a fraction. And before I multiply, I'm going to do what I did last time, and I'm going to see if any number on the top and the bottom of a fraction have anything in common. And I know that 60 and 15 do. I mean, right away I can see that this is going to be divisible by 15. And 15. So that would give me 1. And then 60 divided by 15, I think, is 4. Yep. And so we would do 4 times 4, which is 16, 1 times 1, which is 1. And so we're getting the same answer here. So since we got the same rate of change, our slope, we know that this example would be a proportional relationship. And if you had to just tell me what it meant that there are 16 cookies for every 1 cup of flour. And that's because this first number we wrote down was our y value, and the second was our x value. And y is the number of cookies.
All right, 24 is an involved question because it's dealing with 3 different parts. But we really want to make sure when we do this problem that I want you to see the relationship between a table, a graph, and an equation. So when we're looking at this example, all of these pictures are going to represent the same data or the same information. So let's take a look at the question and read it and see what it says. So it says Giovanni's Chocolates sells chocolate candy by the pound. The cost of chocolate C is proportional to the number of pounds P of chocolate sold. So I want you to think back about when we were talking about proportions and proportional relationships or representations. You saw this in Module 4. Proportional relationships mean that you have to have a graph that goes through 0, 0. So that tells us right away we could plot this. It's going to go through 0, 0. And it also tells you that it's going up or down. Your line is going up or down by the same number, which is our slope. So it has that, it's called constant of proportionality or slope. So it has to have the same slope. And there's a lot of words that mean slope. Rate of change means slope. Constant of proportionality means slope, and you'll learn a lot more later. Now to find that, we have to see what is our change in the y's, which in this case is our c's. And then we're going to divide that by x to figure out what's our proportional relationship slope. What's the slope? Well, let's first look at the table and let's complete the table so that the pattern follows. So let's first look on this side with the pounds. And let's see if we can see a pattern here. Well, we know here there's 1, 2, 3, 4, and 5 of these little boxes. And it goes all the way from 2 to 10. So if we look at the pattern there, it almost looks like it's doing 2, 4, 6, 8, and 10. That's our pattern. It's just going up by 2s each time, or by 2 each time. Now, if we look at the other side with the cost, we want to start with what we know, and let's look at the pattern here. You're asking yourself 22 plus what will give you the 33. And we know that 22 plus 11 gives us 33. Now, if I did 33 plus 11, would I get 44? That's what we need to ask ourselves. 33 plus 11, will that give us 44? And it does. It's following that same pattern. So now if I take 44 and I add 11, I get 55. That would be my blank here. Now if I went backwards, instead of adding 11, I'm going to subtract 11 because I'm going to the previous number. So if it was at 22, if I subtract 11, it becomes 11. So when we read this, what this is telling us, if we look at our table, is it says for every 2 pounds, your cost is $11 per pound. That's how much your chocolate will cost, $11 per 2 pounds. Sorry, per 2 pounds. So let's take all that information now and let's graph it. So look at your graph and take note of a couple of things. Notice that your x-axis is your pounds, so that's your P. And then your y-axis is your cost. And also look at the units. You always want to look. In this case, they're going up by 5s. They're not going up by 1s. So we're going to be cautious of that when we create our graph. So now I'm going to take my very first point, which is the 2 and then the 11, and I'm going to graph it. Remember, the first one is your x and the second one is your y. So for 2 pounds, so I'm going to go over until I hit 2, and then I'm going to go up until I hit 11. And I'm going to plot my dot, which is going to be a little bit difficult here because they are going by 5s on that graph. So it's going to be about there. Now the next thing I want to do is I want to do the same thing with 4. I'm going to go over 4 on my x-axis, and then I'm going to go up until I hit 22. And I'm going to put my dot there. It'll be about right there. And then I'm going to go over 6 on my x-axis. So I'm going this way first. And then I'm going to go up until I hit 33. Oops. And then I'm going to go 8 over until I hit 44. It's way up here. And then 10, I'm going to get 55. So it's going to be over here. So if I were to graph this, and I'm afraid to connect the dots here because it's not going to be easy to make a straight line, but it will make a straight line. That we know that because it says it's proportional. Remember, proportional makes a straight line. It's going up by the same amount each time. Oops, I don't need that. And it goes through 0, 0. So that would be our graph for B. Now for C, it says write an equation that can be used to find the total cost for any number of chocolate. So when we do this, remember, we usually write an equation in the form of y equals mx plus b. And just a reminder, the m is your slope. How much is it going up or going down by each time per 1? And your b is your y-intercept. So it's saying when is the graph crossing the y-axis? What is our initial value? You've also learned it like that, learned it as initial value. What's my initial value here? And your initial value is always at 0. So when I look at my graph, I'm going to replace my y because my y in this example is actually c. I'm going to make it a c equals, that's a variable here. And my slope is how much is it going up each time? Well, if you look at the table or if you look at the graph, what you'll see is that it's $11 for every 2 pounds. So if we wanted to figure out how much it would be going up per 1, we really just need to divide those. So 11 over 2, if we divided that, gave us 5.5. So the reason we did that is because now it tells us that our cost is $5.50 per 1 pound. So that's my slope. I'm just going to make it 5.5x. Now you can leave your slope as 11 over 2. That's the same thing. And I should actually replace my x really quick with a p because my variable in this problem is a p. And then my b represents the initial value, or where is it going through the y-axis. And so we can see that it's going through the y-axis on our graph right here. So I'm just going to make it plus 0. And anytime you have an equation, you don't really need to put plus 0. So if you just put c equals 5.5 times p, that would also be correct.